All right, section 4.3 here, congruent triangles. So we're actually starting to get into talking about two triangles, what it means to be congruent, and also jumping into proofs. So this kind of sets the stage for the rest of the chapter here. All right, so definition of congruent figures. Two figures, and by figures, you know, that can be triangles, that can be squares, it could be pentagons, it could be all kinds of figures, but definition of congruent figures are figures with the exact same size and shape. Okay, they are identical, they're clones of each other. You can flip one, rotate one, and put it, and it'll land exactly on top of the other one. Corresponding angles, I'm going to talk about these in a minute, but corresponding angles means angles that are in the same position, or sometimes I just say that they match up. Same thing with corresponding sides. Those are sides that match up. All right, so some properties of congruent polygons, and I'm really going to be focusing less on polygons and more on triangles. The word polygon just means many sides. That's what polygon means. But a triangle we know has three sides, and that's going to be mainly what we're dealing with here. So let me scroll down a little bit so it's a little bit easier for me to write at my height. All right, so I'm gonna give you a triangle congruent statement. I'm going to say that triangle ABC is congruent to triangle DEF. And this thing right here, this is called a triangle congruence statement, because I'm stating that two triangles are congruent. All right, so what that means is I have two triangles, and I'm going to kind of draw them. And let's just call this one triangle A, B, C. And then over here, I'm going to draw one kind of facing the opposite direction, but coming in. And because of the way this statement is written, triangle ABC, the first letter position was A. And in this other statement, the first letter is D. So that means angles A and D are corresponding to each other. They are the exact same measurement. They are congruent. So A and D match. The second position here, B and E, that means that those two match. So that means my E goes here, and that leaves F for there. So since B and E match, I'm going to put two arcs to show you that those two match. And then finally C and F, those guys match each other as well. So when I talk about, or I refer to corresponding angles, all right, there are three pairs. Angle A is congruent to angle D. Angle B is congruent to angle E. And angle C is congruent to angle F. And with angles, you can have these little marks. Sometimes I'll put them in. If I'm going fast, sometimes I'll leave them out. But you don't have to put them in there. But sometimes it looks like the less than symbol if I'm going too fast. So those are corresponding angles. If I wanted to label corresponding sides, all right, the corresponding sides that match, well, I kind of can look at the marks here, and I see that AC would match up with FD. So segment AC is congruent to segment FD. BC over here matches up with EF, and notice it's between the 2 arc and the 3 arc. Over here we're between the 2 arc and the 3 arc. So BC, and you could reverse these letters. It could be called CB if you'd like. And FE or EF. And then that leaves little old AB over here is congruent or corresponds to ED or DE. So I have 6 pairs. I have 6 of them. I have 3 over here and 3 over here. These are all corresponding parts. So for right now, in order to prove by the definition of congruent triangles, so by the definition of congruent triangles, okay, you must have 3 congruent sides and 3 congruent angles to prove that those two triangles are congruent to each other. You need them all. You got to have all of it. Now, there's going to be some shortcuts later on in the chapter, but for right now, we're trying to get all 6 to match. All right, so let's go down and do a couple examples with that knowledge there. So we're just seeing if you can match pieces up. So in example 1, angle Z is congruent to who? So my picture Z has 2 arcs, so that looks like it would be angle Q. Angle P has 1 arc, so that's going to go with angle Y. They correspond to each other. Those are corresponding parts. Segment NQ, N to Q has 3, so in my other picture it looks like XZ has 3. And I'm just going to not mark all these, but keep going. YZ has 2 arcs, so that looks like it goes with PQ. Angle X has 3 arcs, so that goes with angle N. And PN has 1 tick mark, so that goes with XY. Alright, example 2 is just basically I'm trying to prove that because of this triangle congruent statement, you really don't need the picture. Okay? Once you see the position, so I'm going to just write this down, the position matters. The position of the letters matter big time because I can know what angles go with which angles. So for instance, angle P and angle L match up. So P must be congruent to L because they're both in the first position. Q has to be congruent to M, and R has to be congruent with angle N. Now the sides are a little bit tougher, but not too bad, because just by the way the letters are written, I know that the first 2 letters, segment PQ, must be congruent with segment LM. And I could reverse those letters, there'd be no problem there. Now QR, segment QR, has to go with MN. QR is congruent to MN. And then finally, first and the third, P and R, go with L and N. Segment PR is congruent to LN. Now, if I were to draw the picture out, you would actually see that all of that has to check out. But I just wanted to give you an example to show that you really didn't have to have the picture. Alright, let's move on to the next page and see if we can actually find the length of some sides using that information. So example 3, find each value. We're given our statement, so this tells us who matches up with who. Sometimes it's really obvious just to look at it, but we may want to mark these. So it looks like angle E and R are congruent to each other. So E and R, so I guess I can actually put a little box there because that's 90 degrees. F and S, so the second letters, F and S, so S and F are congruent. And then lastly, G and T go together. So 3 arcs and 3 arcs. Now the sides I can mark by really just looking at the arcs. I'm going to put 1 tick mark between the 1 and 2. It really doesn't matter where I start off with 1 tick mark. I just chose that side. But I look, it's between the 1 and 2 arcs. So I'm going to come over here between the 1 and 2 arcs. I'll put 2 on this one. That's between 1 arc and 3 arc. And then it looks like 3 goes here. And now I can set people up and I can set equations up to solve. So let's try to solve for X. X is right here. And that's angle E. So since angle E and angle R, which we know is 90 degrees, I know that 4X plus 6 has to equal 90 degrees because these two angles correspond to each other. So I set them equal. And I subtract 6 from both sides. And then I divide both sides by 4, and I'll get X equals 21. Going after Y, it looks like Y is involved right here with angle T, and T corresponds with G. So I'm going to put 5Y minus 2, okay, that was angle T, equals 28 degrees, which is angle G. So basically I just said that T is congruent to G. And I'll just substitute the values in, and I'll get 5y equals 30 when I add 2 to both sides, and then when I divide, I'm going to get y equals 6. The measure of angle F. So, well, the measure of angle F shouldn't be too bad because I knew that this was 90 degrees and this one over here is 28 degrees. So when I add those together, that's 118, and I subtract from 180, and that leaves 62 degrees. Now I could have did that a little bit faster. There was a corollary that said if you have a right triangle where this is 90, the other two have to add up to 90. So I could have just did 90 take away 28, and it might have been a little faster. But either way, it doesn't really matter. And finally, what is the distance of S to T? Well, the distance of S to T, well, ST has to match FG. So I'm going to set those two equations equal to each other. 3z subtract 8 has to be equal to z plus 4. And I'm going to get my z's to the left-hand side, so I'm going to minus 1z from both sides. That gives me 2z's subtract 8 equals 4. I'm going to add 8 to both sides. That gives me 12. And then divide both sides by 2. And I find out that z equals 6. Now that's not the answer. Z equals 6, so I need to substitute it in for ST. So 6 plus 4. Looks like that answer is going to come out to be 10 when it's all said and done. So the idea is match up the pieces, okay, match up the pieces and then substitute their values. So here I had angle E had to be congruent to angle R, and I just put the values in. Over here I knew that ST had to be equal to FG. All right, wrapping up these last couple. Class is starting, so I'm on the fly. So find x in the measure of angle F, and I think on this one I would actually have to tell you, I would have to give you a triangle congruent statement and tell you what looks like it matches up with who. So I'm thinking that A and D probably match up. To me it looks like B, and so B up here, and I believe E go together, and then we're going to make C and F. So I will give you this in the future so that you know exactly who matches up with who. So finding X, I basically can set this up, and so it looks like the side that's between the 90 and the 2 arc is between the 90 and the 2 arc. So 2x subtract 2 equals 6. Add 2 to both sides and divide, and I'm here. And then if I need to find angle F, let's see, so if this is 90 and I have 53, that's 37 over here, and C and F match, so that would be 37. So the measure of angle C is 37 degrees. We're going to do the proof on the bottom in class, so hold off on that. See ya.